Okay, so this video will look at how to write ionic equations for precipitation reactions. So let's say you need to make lead to iodide. Well, lead to iodide is going to be a precipitate. And if we go back to our solubility rules, we know that most halides are soluble except silver chloride, silver bromide and silver iodide. However, this should also include lead 2 chloride, lead 2 bromide and lead 2 iodide. Okay, so they'll be a solid. So how do we make precipitates? We've covered this before. You make a precipitate by mixing 2 salts. So I need a lead 2 salt and I need something containing iodide. Well, again, if I go back to my solubility rules, I know that all nitrates, which is NO3 minus, are soluble. So the best thing you can do is use lead 2 nitrate. Now I need a soluble iodide salt. Going back to this, I know all group 1 and ammonium compounds are soluble. So I'm just going to use sodium iodide. So this will make my lead 2 iodide precipitate. Let's just bring this down here so it's just all on one line. And sodium nitrate. So we've got our word equation. Right, now all we need to do is write our balanced simple equation. So lead 2 nitrate, Pb, NO3, the charge of lead is 2, because lead 2, nitrate is -1. If we swap those over, I need 1 lead and 2 nitrates. So brackets, multiply that one by 2. And then sodium iodide, Na and I. Sodium is in group 1, so valency 1. Iodide is in group 7, so it's a -1 charge, valency 1, so it's just NaI. That goes to lead 2 iodide. Okay. Lead charge +2, iodide -1, so if we dropped and swapped that, it'd be PbI2. Sodium nitrate, sodium group 1 has a charge of +1, nitrate NO3 minus, so they cancel out NaNO3. Okay, then to balance this, we do 2 of those, okay, because we have 2 nitrates here, and then because we've got 2 iodides, I'm then going to multiply that by 2. So I've now balanced my equation. Final thing I need to do is state symbols. So it's looking at lead 2 nitrate, it's aqueous because all nitrates are soluble. Sodium iodide is aqueous because all group 1s are soluble. Most halides are soluble except lead 2 iodide, so that's going to be a solid, it's our precipitate, and the sodium nitrate is aqueous. So a precipitation reaction is when we mix 2 aqueous salts to make a solid precipitate. Now, turning this into an ionic equation, anything that's ionic we split up into its respective ions. So what does this mean? Well, lead 2 iodide is made up of Pb2+ and 2 lots of nitrate ions. So plus 2 times NO3 minus. We bring the 2 out in front when we do the ionic equation because it's telling me I've got 2 lots of them. It's no longer bound within the compound. Both of these were aqueous before, so we put AQ there. Okay. And just because I keep all the reactants on the left-hand side, I'm going to write below for the sodium iodide now, I have Na plus aqueous and I minus aqueous. They're what make up sodium iodide, but because we've got a big 2 out in front of it, we multiply everything by 2, so it's 2Na plus, 2I minus. See if you can do the same on the right-hand side. Probably pause this video and then see if you can do the answer afterwards. So going through the answer then, this remains PbI I2 solid. Because it is a solid, it's not going to dissociate up into its respective ions. Okay, so that remains as is. If we then deal with the sodium nitrate, our final product, that's made up of Na plus, NO3 minus, both of which are aqueous. However, again, because we're multiplying both of those by 2, it's 2Na plus, 2NO3 minus. So you've got the beginning part of the ionic equation, and the final step is just to simplify. Anything that's on the left-hand side, which remains the same on the right-hand side, they cancel down. For instance, I've got 2 nitrates as my reactants, 2 nitrates as my product, okay, so we can get rid of those. I have 2 sodium ions as reactants and products, so I can get rid of those. And then you have your final equation, which is Pb2 plus aqueous plus 2I minus goes to Pbi2 solid. You'll find for precipitation reactions, you're effectively just getting the ions that make up the precipitate and then put them on the reactant side. Everything else will be a spectator, so anything that cancels down is called a spectator ion, and they won't be in there. So we could have used any lead 2 salt that's soluble and any iodide salt that's soluble. So for instance, if we had used potassium iodide instead of sodium iodide, it won't appear in our final ionic equation because it'd be a spectator.